November the 8th, 1942. Outside Mejez el Bab, Tunisia. The morning sun cast long shadows across the rocky terrain as Unteroffizier Klaus Richter of the Afrika Korps crouched behind a disabled Sterd QFZ 251 half-track, scanning the American positions through his field glasses. His squad had been fighting these green American troops for 3 days now, and the Germans were beginning to understand their enemy's equipment. That morning, they had captured something interesting. An odd-looking steel tube about 5 feet long, discarded in a hasty American retreat. One of Richter's men, a former metal worker from Stuttgart, examined it with amusement. This is their secret weapon? It looks like something a plumber left behind. The Americans think they can stop our panzers with a pipe? The laughter rippled through the German positions. Within days, captured examples of this curious American weapon would be shipped back to Germany, where engineers would study it with far more serious intent. But in that moment, standing in the Tunisian desert, German infantry had no idea they were holding the prototype for their own salvation. They certainly didn't know that within 18 months the Germans would be producing their own enlarged version, or that a decade later an improved American design would make German mockery turn to grudging respect, then outright fear. The weapon they were laughing at was the M20 Bazooka, and its evolution would change infantry anti-tank warfare forever. The story of the bazooka begins not in the factories of wartime America, but in the mind of a visionary rocket scientist working decades earlier. Robert Goddard, the man who would become known as the father of modern rocketry, first demonstrated a tube-launched rocket weapon to the United States Army Signal Corps at Aberdeen Proving Ground, Maryland, on November 6, 1918. The timing couldn't have been worse. 5 days later, the armistice was signed, ending World War I. The Army, eager to demobilize and return to peacetime, showed zero interest in developing what seemed like an experimental curiosity. Goddard himself contracted tuberculosis and turned his attention to other rocket projects. His partner, Dr. Clarence Hickman, filed the concept away for future consideration. That future would arrive 23 years later, when the world was again at war. By 1941, the problem was clear to anyone paying attention. Tanks had evolved dramatically since the Great War. The lumbering, vulnerable machines that had crossed the Somme in 1916 had been replaced by fast, heavily armoured vehicles mounting powerful guns. The German panzer divisions that had smashed through Poland and France demonstrated that armour, properly employed, could decide battles before infantry even engaged. The US Army, watching from across the Atlantic, recognised they needed to give their foot soldiers a way to fight back against tanks. Traditional anti-tank rifles were essentially useless against modern armour. Anti-tank guns were effective but heavy, requiring crews and vehicles to move them. What the infantry needed was something a single soldier, or at most a two-man team, could carry and employ against approaching armour. They needed portable firepower that could penetrate steel plate. The solution came from combining two existing technologies. American engineers had developed a shaped charge hand grenade, designated the M10, that could defeat up to 60 millimeters of armour plate. The hollow charge principle, where an explosive shapes its blast into a focused jet of superheated metal and gas, could punch through steel that would laugh off conventional explosives. The problem was weight. At 3.5 pounds, the M10 was too heavy to throw effectively. Soldiers couldn't hurl it far enough to be safe from the blast, and certainly couldn't throw it accurately at a moving tank. What they needed was a way to deliver this shaped charge from a safe distance with reasonable accuracy. In early 1942, Captain Leslie Skinner and Lieutenant Edward Oule, working at the Aberdeen Proving Ground, were tasked with solving this delivery problem. The Army was testing various spigot mortars, devices that would launch the shaped charge grenades from a fixed platform. None performed well. During a break in testing, Oule noticed a steel tube in a scrap pile. The tube's diameter matched the M10 grenade almost perfectly. In that moment, Oule had his breakthrough. Instead of trying to launch the grenade from a complex mortar, why not simply fire a rocket-propelled version through a smooth tube? The operator could aim the tube like a rifle. The rocket motor would provide velocity and range, and the backblast would exit harmlessly behind the firer. Oule and Skinner worked frantically to develop a working prototype. They added stabilizing fins to the rocket, designed an electrical firing system, and fabricated crude sights from a bent wire coat hanger. In May 1942, they demonstrated their creation at Aberdeen. The test was supposed to evaluate various anti-tank weapons against a moving tank target. Every other system, including the expensive and complex Spigot mortars, missed completely. The improvised rocket launcher, with its coat-hanger sights, scored multiple hits. The observers were astonished. This crude tube weapon, assembled in weeks, outperformed systems that had been in development for years. The weapon was immediately approved for production and designated the 2.36-inch rocket launcher M1. The rocket itself, containing 8 ounces of pentalite explosive in a shaped charge configuration, was designated the M6. But neither of these official designations would stick in the public consciousness. When Brigadier General Gladian Barnes of the Ordnance Department first saw the weapon, he reportedly laughed and said it looked like Bob Burns' Bazooka. Burns was a popular radio comedian of the era who played a bizarre musical instrument he had invented from stovepipes and a whiskey funnel, which he called a bazooka. The name was perfect. Within weeks, every soldier referred to the new weapon as the bazooka, and the name became permanent. Production ramped up with impressive speed, typical of American wartime industry. General Electric's Bridgeport facility received the contract and began churning out launchers. The E.G. Budd Company manufactured the rockets. By November 1942, enough bazookas had been produced to equip some of the US forces participating in Operation Torch, the Allied invasion of North Africa. This would be the weapon's combat debut, and it would not go well. The problems began before a shot was fired. General Dwight Eisenhower, commanding the invasion, was shocked to discover the night before the landings that none of his troops had received any training on the bazooka. The weapon had been rushed into production and shipped overseas so quickly that there hadn't been time to train the men who would use it. Compounding this problem, the early M6 rockets proved highly unreliable. Many failed to ignite when fired. Others detonated prematurely or not at all. The battery-powered firing system was fragile and easily damaged during the rough handling of combat conditions. Moisture, common in amphibious operations, wreaked havoc with the electrical components. When American forces finally engaged German armour in Tunisia, the bazooka's performance was dismal. An American general visiting the front after the initial fighting reported that he couldn't find a single soldier who could confirm the weapon had actually stopped an enemy tank. Hits that should have been devastating bounced off or failed to penetrate. The M6 rocket's pointed nose had a tendency to deflect when striking sloped armour at an angle, exactly the kind of armour geometry the Germans favoured. German tankers, initially concerned about this new American weapon, quickly realised it posed minimal threat. More significantly, German infantry recovered several discarded or captured bazookas from the battlefield. These captured weapons were immediately shipped to Germany for analysis. German engineers examined them with professional interest. The concept was sound, even elegant in its simplicity. But the execution was flawed, and the calibre was inadequate for the thick armour German tanks now carried. Within months, German designers were working on their own version, one that would address the bazooka's shortcomings, while scaling up the destructive power. They would call it the Panzerschreck, Tank Terror, and it would prove far more effective than the weapon that inspired it. By May 1943, the US Army temporarily suspended further issue of the M1 bazooka pending improvements. The weapon's reputation among American infantry was already poor. Stories circulated of soldiers firing entire loads of rockets at German tanks with no effect. The shaped charge warhead simply couldn't penetrate the frontal armour of German medium and heavy tanks. Even hits on thinner side armour often failed to disable vehicles. Crews assigned to bazooka teams began to see the duty as nearly suicidal. You had to get close enough to a tank to ensure a hit, close enough to see the faces of the crew through the vision ports, but your weapon might not even work. The mortality rate among bazooka operators was staggering. The Army responded with improvements. The M1A1 variant incorporated a simplified design and better manufacturing standards. More importantly, engineers redesigned the rocket. The M6A1 featured a redesigned nose, though it still suffered from deflection problems. Then came the M6A3, with a fully rounded, blunted nose that would not deflect off angled armour, and improved fins for better stability in flight. This combination could penetrate 3.5 to 4 inches of armour plate, enough to threaten most German tanks if you could hit them in the right spot. The redesigned bazooka saw limited use during the Allied invasion of Sicily in July 1943. Small numbers of M1A1 launchers firing M6A3 rockets were issued to American forces. The results were better, but only marginally. The weapon was credited with destroying 5 German tanks during the Sicilian campaign, including 1 Tiger I heavy tank, though that particular kill came from an incredibly lucky shot through the driver's vision slot. Against the Tiger's frontal armour, which exceeded 100mm in thickness, the bazooka was essentially useless. Even the thinner side armour of German heavy tanks resisted the 2.36-inch warhead, unless the hit was nearly perpendicular. German infantry, meanwhile, were receiving their own improved anti-tank weapons. In late 1943, the Panzerschreck entered production. Based directly on captured American bazookas, the German version featured an 88mm caliber compared to the bazooka's 60mm. This larger warhead could penetrate up to 160mm of armour, enough to threaten any Allied tank from any angle. The Panzerschreck was heavier and produced tremendous backblast, requiring operators to wear protective ponchos and gas masks, but it worked. German infantry, who had initially mocked the American bazooka as a plumber's pipe, now had a weapon that made Allied tank crews genuinely nervous. Even more devastating was the Panzerfaust, a disposable single-shot weapon that was cheaper to produce and nearly as effective. By late 1943, the US Army was developing an improved bazooka, the M9. This variant could be broken down into 2 sections for easier transport, particularly valuable for paratroopers. It featured a forward blast deflector, better sights, and used the improved M6A3 rocket. The firing system was changed from battery power to a magneto system, addressing one of the original weapon's most persistent reliability problems. The M9 began reaching troops in 1944 and proved more reliable than its predecessor, but it still fired the same 2.36-inch rocket, and as German tanks grew heavier and more heavily armoured, even the improved bazooka struggled. Reports from the European theatre in 1944 and 1945 told a sobering story. Against the Panzer IV, the standard German medium tank, the bazooka could achieve kills if it hit the side or rear armour. Frontal shots were risky at best. Against the Panther with its heavily sloped frontal armour, the bazooka was nearly useless except from the sides or rear. Against the Tiger and Tiger II, American infantry learned to avoid engagement entirely unless they could arrange an ambush from extremely close range attacking the thinner rear armour. The mathematical reality was stark. The shaped charge jet from a 2.36-inch warhead could penetrate about 110 to 120 millimeters of vertical armour plate. German heavy tanks had frontal armour exceeding this, and their sloped armour geometry effectively increased protection even further. General George Patton, in a letter dated May 20, 1944, articulated the grim reality. The purpose of the bazooka is not to hunt tanks offensively, but to be used as a last resort in keeping tanks from overrunning infantry. To ensure this, the range should be held to around 30 yards. 30 yards, close enough to see the rust on the tank's exhaust pipes, close enough to hear the squeal of the bogey wheels, close enough that if your rocket failed to penetrate, you'd likely die in the next few seconds. Assignment to a bazooka team was informally known as Medal of Honor work, a dark joke about the high likelihood of posthumous recognition. In the Pacific Theatre, the bazooka found more success, but not against tanks. Japanese armour was generally lighter and less sophisticated than German vehicles, making the 2.36-inch warhead more effective when tank targets presented themselves. But the real value came from using bazookas against bunkers and fortified positions. Japanese defensive works, particularly the reinforced concrete pillboxes on islands like Iwo Jima and Okinawa, were vulnerable to shaped charge warheads. A bazooka team could destroy a machine gun nest from relative safety, something that would otherwise require infantry to charge the position with satchel charges or flamethrowers. Against Japanese positions built from coconut logs, earth, and sand, the bazooka was less effective, as the soft materials didn't provide enough resistance for the shaped charge to function properly. But against concrete and steel, it was devastating. Even as the M9 bazooka proved itself in the Pacific, American ordnance officers recognized that the basic design had reached its limits. In October 1944, work began on the T-74, an experimental 3.5-inch launcher. The Germans had demonstrated with the Panzerschreck that a larger caliber could dramatically improve penetration. American engineers studying captured Panzerschrecks decided to match the German 88mm caliber, which translated to 3.5 inches in American measurements. The T-74 used an aluminum alloy barrel to keep weight manageable, despite the larger size. It fired a 9-pound rocket carrying 2 pounds of explosive, compared to the M9's 3.5-pound rocket with 8 ounces of explosive. The larger warhead could theoretically penetrate 11 inches of armour, enough to defeat any tank in existence. But development was slow, and the war in Europe ended before the new weapon could be deployed. With Germany defeated and Japan on the verge of collapse, the urgency faded. The T-74 was refined and standardized as the M20 Super Bazooka, but production was minimal. The Pentagon, focused on the new reality of atomic warfare, saw less need for conventional infantry anti-tank weapons. In the new doctrine, nuclear weapons would destroy enemy armoured formations, and infantry would simply mop up survivors. The M20 was manufactured in small numbers and placed in storage. The war ended. The troops came home. The 2.36-inch M9 bazooka remained the standard infantry anti-tank weapon, deemed sufficient for peacetime needs. 5 years later, this complacency would prove catastrophic. On June 25, 1950, the North Korean People's Army crossed the 38th parallel and invaded South Korea. Leading the attack were 242 Soviet-supplied T-34-85 medium tanks, the same vehicles that had spearheaded the Red Army's drive to Berlin. The South Korean army, caught completely by surprise and equipped with virtually no anti-tank weapons, collapsed in chaos. Within 3 days, Seoul had fallen. The United States, committed to defending South Korea, immediately ordered troops from occupation duty in Japan to deploy to the peninsula. The soldiers who boarded transport aircraft in early July 1950 were from the 24th Infantry Division, primarily the 21st Infantry Regiment. They had spent the previous 5 years on occupation duty in Japan, a comfortable posting that involved more ceremony than combat training. Most were young draftees with minimal training, and their equipment reflected the post-war drawdown. The heavy weapons they carried to Korea were largely World War II surplus that had been sitting in storage since 1945. This included M9 and M9A1 bazookas, with rockets that had been improperly stored in the humid Japanese climate for years. On July 1st, Lieutenant Colonel Charles B. Smith received orders to take a reinforced battalion-sized task force to Korea and delay the North Korean advance. His mission was vague, his intelligence minimal, and his preparation non-existent. By July 4th, Task Force Smith, comprising about 540 men, had dug in on hills overlooking the main road near Osan, south of Seoul. They had 6 105mm howitzers, several mortars, a handful of machine guns, 2 75mm recoilless rifles, and 6 2.36-inch bazookas. Against the tanks, they possessed exactly 6 high-explosive anti-tank rounds for the howitzers. That was 1/3 of the total heat ammunition available to US forces in all of Asia at that moment. At 7:30 a.m. on July 5, 1950, the Americans spotted 8 T-34 tanks approaching down the highway. As the range closed, the forward howitzer, positioned to ambush the column, opened fire with its precious heat rounds. At point-blank range, Corporal Herman Critchfield and his crew managed to disable 2 tanks, setting one ablaze. But then their heat ammunition was exhausted, and they switched to standard high-explosive shells, which simply bounced off the T-34's armour. The tank column kept coming. Behind the first 8 tanks came 25 more, and behind them thousands of North Korean infantry. Second Lieutenant Ollie Connor, positioned on the hillside with his bazooka team, watched the tanks approach. As a T-34 rumbled past his position, at a range of just 15 yards, Connor fired. The rocket struck the tank's rear armour where the steel was thinnest. Nothing happened. The tank didn't even slow down. Connor fired again and again. In total, he fired 22 rockets at T-34 tanks from point-blank range, hitting them repeatedly in their most vulnerable spots. Not a single rocket penetrated. Some failed to ignite. Others detonated, but the warhead couldn't punch through even the T-34's relatively thin rear armour. The tanks, apparently assuming the roadblock was manned by South Korean troops and posed no serious threat, simply ignored the bazooka fire and continued south. The horror of that moment cannot be overstated. American infantry, equipped with what was supposed to be their primary anti-tank weapon, watched helplessly as enemy tanks rumbled past them at distances where they could have hit the vehicles with thrown rocks. The bazookas were useless. Worse than useless, because their failure destroyed morale and created panic. Within hours, Task Force Smith's position was overrun. The unit retreated in disorder, leaving behind 20 dead, 130 wounded or missing, and most of their equipment. The Battle of Osan lasted 7 hours and accomplished nothing except to demonstrate that the US Army was completely unprepared for conventional warfare against modern Soviet equipment. The disaster at Osan sent shockwaves through the American military. General Douglas MacArthur, commanding US forces in the Far East, immediately demanded better anti-tank weapons. Reports from the battlefield were rushed to Washington. The 236-inch bazooka, effective enough against World War II German armour when employed correctly, was completely outmatched by the T-34. The Soviet tank's armour ranged from 0.79 inches on the thinnest panels to 3.54 inches on the front. The M9's shaped charge warhead, capable of penetrating about 4 inches of vertical armour under ideal conditions, simply couldn't defeat the T-34's combination of thickness and slope. Even hits on the side and rear armour, where most tanks are vulnerable, failed to penetrate. The failure wasn't entirely due to inadequate penetration. Many of the rockets had been in storage since 1945, improperly maintained in Japan's humid climate. The propellant had degraded, reducing velocity. The shaped charge explosive had deteriorated, reducing effectiveness. The electrical firing systems had corroded, but even with fresh ammunition, the fundamental problem remained. The 2.36-inch warhead was too small. American infantry needed a bigger bazooka, and they needed it immediately. Fortunately, the weapon already existed. The M20 Super Bazooka, developed in 1944 and 45 but never mass-produced, sat in storage at Rock Island Arsenal in Illinois. On July 8, 1950, just 3 days after the disaster at Osan, the desperate situation intensified. Colonel Robert Martin of the 24th Infantry Division was killed attempting to stop a T-34 with a 2.36-inch bazooka, becoming one of the highest-ranking American officers killed in the early days of the war. MacArthur's request for the Super Bazooka turned into urgent demands. The Pentagon ordered Rock Island Arsenal to ship every available M20 immediately. On July 12, 1950, just 7 days after Task Force Smith's defeat, transport aircraft loaded with M20 Super Bazookas took off from Illinois. This marked the first time equipment was shipped directly from a US arsenal to troops in the field using air transport, bypassing normal supply channels entirely. The weapons were accompanied by instructors who would train soldiers on the new system in the field. The manual for the M20 was written at Fort Benning in just 2 weeks, a process that normally took months. By July 18th, the first Super Bazookas reached the 24th Infantry Division in time for the battle at Dijon. The M20 was an impressive weapon. At 60 inches long and weighing 14.3 pounds empty, it was larger and heavier than the M9, but not prohibitively so. The aluminum alloy barrel kept weight manageable despite the increased size. Like the late model M9, it broke down into 2 sections for transport. The real difference was the ammunition. The M28A2 rocket weighed 9 pounds and measured 3.5 inches in diameter. It carried a shaped charge warhead containing 2 pounds of Composition B explosive, a mixture of RDX and TNT that was among the most powerful explosives available. This warhead could penetrate 11 inches of homogeneous armour plate, enough to punch through a T-34's frontal armour with room to spare. When the Super Bazooka first saw action on July 18th at Dijon, the results were immediate and dramatic. The 24th Infantry Division claimed 8 T-34s destroyed in that single engagement. For the first time since the war began, American infantry could fight back against North Korean armour. The shaped charge jet from the 3.5-inch warhead didn't just penetrate the T-34, it devastated the interior, setting off ammunition and killing the crew. North Korean tank crews, who had grown accustomed to shrugging off American infantry anti-tank fire, suddenly faced a weapon that could kill them. Major General William F. Dean, commanding the 24th Infantry Division, personally used a Super Bazooka against T-34s during the fighting around Dijon. Dean would later be captured and spend nearly 3 years as a prisoner of war, but his bravery in those early desperate days earned him the Medal of Honor. His actions also demonstrated what the new weapon could do in determined hands. The Super Bazooka gave American infantry the confidence to stand and fight, rather than retreat in panic when tanks appeared. By August 1950, production of the M20 ramped up to full capacity. Rock Island Arsenal and other facilities were churning out hundreds of launchers per week. Every unit arriving in Korea came fully equipped with Super Bazookas. Units already in theatre were rapidly re-equipped, and the old 2.36-inch weapons were relegated to storage or shipped to rear areas. Some of these obsolete bazookas were eventually captured by North Korean forces, who tried to use them against American M26 Pershing and M4 Sherman tanks. The 2.36-inch rockets proved somewhat effective against the thinner armour of the Sherman, though even there they were marginal. Against the Pershing's frontal armour, they were useless, giving American tankers a taste of the frustration their infantry had experienced. The Super Bazooka transformed infantry anti-tank tactics. The effective range was about 300 yards under ideal conditions, though realistic combat ranges were much shorter, typically 100 yards or less. The magneto firing system proved reliable even in Korea's extreme weather, from summer heat to brutal winter cold. The sights were accurate enough for aimed fire at moving targets. Most importantly, the weapon worked. When you fired the M20 at a tank, you expected to kill it, and usually did. The psychological impact on North Korean tank crews was profound. The T-34s that had seemed invincible in July were burning wrecks by September. The transformation wasn't limited to American forces. When United Nations forces, including British Commonwealth units, deployed to Korea, they were equipped with M20s under Lend-Lease arrangements. Australian infantry used them to great effect in October 1950, destroying multiple North Korean T-34s during the fighting around the Pusan perimeter. The British designated the M20 as the M20 MCOL-1, later updating to the M20A1 as the M20 MCOL-2. In British service, the Super Bazooka would remain standard issue into the mid-1960s, when it was finally replaced by the Swedish Carl Gustaf recoilless rifle. The Chinese intervention in November 1950 brought new challenges. The Chinese People's Volunteer Army crossed the Yalu River with hundreds of thousands of troops, but relatively few tanks. When Chinese armour did appear, it was usually Soviet-supplied T-34-85s or Su-76M self-propelled guns, and the M20 proved effective against both. More commonly, the Super Bazooka was used against fortified positions. Chinese forces were masters of defensive warfare, digging into mountainsides and creating bunker complexes that were extraordinarily difficult to assault. The M20's 9-pound rocket, while designed for anti-tank work, proved devastatingly effective against bunkers. The shaped charge warhead could blast through reinforced positions, and the sheer explosive force would collapse tunnels or seal cave openings. Interestingly, the North Korean People's Army lost 239 T-34-85 tanks and 74 Su-76M self-propelled guns during the Korean War, but the vast majority fell victim to American aircraft and medium tanks, not bazookas. Infantry anti-tank engagements were relatively rare, simply because North Korean armour, after the initial devastating losses in 1950, became extremely cautious. Tank crews learned quickly that advancing without infantry support or reconnaissance was suicidal. The M20's reputation preceded it. North Korean and Chinese forces treated American bazooka teams with extreme respect, targeting them preferentially with artillery and machine gun fire. The Super Bazooka did have limitations. The 3.5-inch rocket produced significant backblast, requiring operators to ensure the area behind them was clear for at least 30 feet. Firing from enclosed spaces like rooms or bunkers was dangerous, as the backblast could injure the crew and the smoke revealed the firing position immediately. The weapon was most effective at relatively close range, under 150 yards for moving targets. The rocket's time of flight meant that targets moving at speed could travel several feet between launch and impact, requiring significant lead. Loading was slower than ideal, with a practical rate of fire of about 6 rounds per minute, under good conditions, slower in combat. As the Korean War transitioned from mobile warfare to static trench fighting in 1951 and 52, the role of the Super Bazooka evolved. Tank versus bazooka engagements became rare. Instead, the M20 became the infantry's portable artillery, used to destroy bunkers, machine gun nests, and fortified positions. It was more effective in this role than the 57mm and 75mm recoilless rifles that were also available, because the shaped charge warhead was more effective against reinforced structures than the high explosive rounds fired by recoilless rifles. Some American units even reduced their Super Bazooka allocation, replacing bazooka teams with additional machine gun crews, on the theory that fire support from recoilless rifles and tanks made the specialized anti-tank weapon less critical in positional warfare. The Super Bazooka's success in Korea led to widespread adoption by US allies. By 1953, the South Korean military had received over 4,900 M20s, completely replacing their earlier 2.36-inch weapons. The French army adopted the Super Bazooka as their standard infantry anti-tank weapon, and used it extensively during the colonial wars in Indochina and Algeria. West Germany, ironically, equipped their new Bundeswehr with American M20s, the spiritual descendant of their own Panzerschreck. Nations across Latin America, the Middle East, and Asia purchased or received Super Bazookas through military aid programs. The weapon became ubiquitous in Cold War conflicts. Some nations even developed their own variants. Spain's Instalaza company produced an improved M20 designated the M65, which used a solid-state firing circuit powered by batteries instead of the magneto system, along with improved rockets. This version served the Spanish army into the 1970s. China, which had captured large numbers of 2.36-inch and 3.5-inch bazookas during the Chinese Civil War and Korean War, reverse-engineered the M20 as the Type 51. The Chinese version had a 90mm caliber, slightly larger than the American 3.5-inch, and could fire captured American rockets, though American bazookas couldn't fire Chinese ammunition due to the size difference. These Type 51 launchers were widely exported to communist allies and guerrilla movements, seeing action in Vietnam, the Middle East, and Africa. The Super Bazooka served in American infantry through the early stages of the Vietnam War. Marine units deployed to Vietnam in 1965 carried M20s and M20A1B1 variants. In the jungle environment, opportunities to engage armour were rare, as North Vietnamese and Viet Cong forces operated few tanks. Instead, like in Korea, the bazooka's primary role was bunker busting and destroying fortified positions. The shaped charge warhead was effective at blasting through the reinforced firing points and tunnel entrances that characterized Vietnamese communist defensive works. However, the weapon's weight and bulk, combined with limited anti-tank requirements, led to its gradual replacement by the lighter M72 Law, the light anti-tank weapon, a 66mm disposable single-shot rocket launcher that weighed just 5.5 pounds loaded. By the mid-1960s, the M20 was being phased out of American service. The M67 90mm recoilless rifle and M72 Law offered better range and comparable penetration with less weight. The Super Bazooka lingered in National Guard and Reserve units into the early 1970s, but frontline forces had moved on to more modern systems. The final American chapter of the bazooka story closed with the adoption of the M47 Dragon in 1975, and later the BGM-71 TO, wire-guided anti-tank missiles that could engage targets at ranges exceeding 2,000 yards with near-certain kills. But the Super Bazooka's service life continued elsewhere. During the Falklands War in 1982, Argentine forces used M20s against British troops. The British, who had only recently retired their own Super Bazookas, faced the possibility of their light armoured vehicles being destroyed by the same weapon they had once relied upon. In that conflict, Argentine infantry positions equipped with M20s posed a real threat to the Scorpion and Scimitar light tanks of the British reconnaissance units, though few actual engagements occurred. Various conflicts throughout the 1980s and 90s saw M20s in use by irregular forces and second-tier militaries, a testament to the weapon's reliability and effectiveness even decades after its introduction. The story of the bazooka, from mockery to mastery, reflects a broader truth about military technology. The M1 and M9 bazookas, rushed into production and deployed with inadequate training and unreliable ammunition, earned their poor reputation honestly. German infantry in Tunisia in 1942 and 43 had every reason to laugh at the American pipe that couldn't stop their tanks. But the fundamental concept was sound, and American industry, when properly motivated, could iterate and improve with remarkable speed. The Super Bazooka that arrived in Korea in 1950 was everything the original should have been, a weapon that gave infantry genuine capability against armour, that worked reliably under harsh conditions, and that earned the respect of friend and foe alike. The German infantry who had mocked the bazooka in 1942 learned their lesson when the Panzerschreck, based on that same mocked weapon, became one of their most effective anti-tank systems. The North Korean tank crews who had contemptuously ignored American bazookas in July 1950 learned a far more brutal lesson just weeks later when the 3.5-inch rockets started punching through their T-34s. The transformation from joke to genuine threat took less than a decade, but the lessons learned influenced infantry anti-tank warfare for the rest of the 20th century. In the end, more than 300,000 Super Bazookas were produced, seeing service with dozens of nations. The weapon proved that man-portable anti-tank capability was achievable, practical, and essential. It demonstrated that shaped charge technology, properly scaled and reliably delivered, could give individual soldiers the ability to destroy multi-ton armoured vehicles. It showed that rapid iteration and improvement, driven by combat necessity, could turn a flawed concept into an effective weapon system. And it reminded everyone who had ever underestimated American military technology that mockery often turns to respect, sometimes very quickly, and usually under circumstances that make the lesson painful to learn. The bazooka's evolution from Tunisia to Korea is not just the story of a weapon, it's the story of how industrial capacity, combat experience, and engineering determination can transform failure into success. German infantry laughed at early bazookas. By the time the Super Bazooka arrived, no one was laughing anymore. The technical evolution of the Super Bazooka didn't end with its successful deployment in Korea. Throughout the 1950s, improvements continued as engineers refined the weapon based on combat feedback and advances in materials science. The M20A1 variant, standardized in 1952, incorporated several crucial improvements. The barrel was reinforced at key stress points, extending service life. The optical sight was upgraded from the simple iron sights of early models to a more sophisticated ranging system that accounted for the rocket's trajectory drop at various distances. Most significantly, the M20A1 featured an improved venturi nozzle at the rear of the barrel that more efficiently directed the rocket's exhaust, reducing the danger zone behind the weapon and slightly improving accuracy. The ammunition also evolved. The original M28A2 rocket had used a point-detonating piezoelectric fuse that sometimes failed on glancing hits against sloped armour. The improved fuse design incorporated a crush switch that would reliably detonate even if the rocket struck at an oblique angle. Engineers also developed specialized ammunition for different roles. The M29A2 practice round allowed training without expending expensive combat rockets. The M30 white phosphorus round transformed the bazooka into an area denial weapon, useful for marking targets or creating smoke screens. Most interesting was the M31 heat round, introduced in 1953, which featured an extended probe fuse that stood off from the warhead, allowing the shaped charge to form more effectively before contact with armour. This increased penetration to nearly 13 inches, enough to defeat the frontal armour of the Soviet IS-3 heavy tank, the most heavily armoured vehicle in existence at the time. Veterans who used both the 2.36-inch and 3.5-inch bazookas in combat universally praised the Super Bazooka's superiority. Staff Sergeant David Williams, who had carried an M9 through the Philippines in 1944 and 45, then found himself back in combat in Korea with an M20. Later recalled in an interview for the Army's oral history program, "It was night and day. The old bazooka, you fired it and prayed. The new one, you fired it and expected results. I knocked out 2 T-34s in September 1950, both frontal hits at about 80 yards. The first one brewed up immediately, flames shooting out of every hatch. The second took 2 hits, but it stopped dead. With the old bazooka, I wouldn't have even tried engaging from the front. I'd have waited for a flank shot or just called for tank support. The Super Bazooka gave us confidence. That's what really changed. We stopped being terrified of enemy armour and started seeing tanks as targets we could actually kill." This psychological transformation cannot be overstated. In World War II, particularly during the early campaigns in North Africa and Italy, German armour had acquired an almost mythical reputation among Allied infantry. The Tiger tank especially became a bogeyman, its reputation for invincibility far exceeding its actual tactical impact. American soldiers would report Tigers when facing any German tank, simply because the name had become synonymous with unstoppable armour. The inadequacy of early anti-tank weapons reinforced this fear. When your bazooka couldn't penetrate, every enemy tank became a Tiger in your mind. The Super Bazooka broke this psychological barrier. For the first time, American infantry had a man-portable weapon they truly believed could kill any tank they encountered. The training program for the M20 also represented a significant improvement over the haphazard introduction of the original bazooka. By 1951, every infantryman in basic training received instruction on the Super Bazooka, even if they weren't assigned to a bazooka team. The army had learned from the disaster at Osan that weapons rushed to the front without proper training were worse than useless. The standard training regimen included classroom instruction on the weapon's operation and maintenance, dummy rocket loading drills, dry firing exercises, and live fire qualification against stationary and moving targets. Advanced courses taught tactics, how to select firing positions, how to lead moving targets, how to coordinate with supporting infantry, and critically, when not to engage. This last point was emphasized repeatedly. The Super Bazooka was not a tank hunting weapon in the offensive sense. Its effective range of 100 to 150 yards meant that bazooka teams operating aggressively against armor were likely to be killed before achieving firing position. The weapon was fundamentally defensive, designed to stop armor that was overrunning infantry positions or to ambush vehicles moving through restricted terrain. The training manuals were explicit. The bazooka team's job was not to seek out and destroy enemy armor, but to prevent enemy armor from destroying friendly infantry. This defensive doctrine, learned through hard experience, kept casualties among bazooka operators from being even more catastrophic than they were. The two-man bazooka team became a fixture of American infantry organization. The gunner carried the launcher and 3 rockets, a total load of about 40 pounds. The assistant gunner carried an additional 5 rockets, another 45 pounds, plus a rifle for self-defense. In practice, nearby soldiers often carried extra rockets, distributing the load across the squad. This was necessary because 8 rockets, the theoretical combat load for a two-man team, was rarely sufficient. Combat reports from Korea indicated that the average bazooka engagement that resulted in a tank kill required 2.3 rockets, meaning a team could expect to destroy 3 or 4 tanks before exhausting their ammunition, assuming perfect conditions. In reality, missed shots, malfunctions, and targets escaping behind cover meant that 8 rockets might only guarantee 1 or 2 kills. The tactical employment of bazooka teams required careful thought. The weapon's backblast signature was enormous, a roaring jet of flame and smoke that revealed the firing position to every enemy within several hundred yards. Firing from a fighting hole required that the hole be at least 6 feet deep and face away from expected enemy positions, or the backblast would shower the crew with debris. Firing from buildings required open windows or blown-out walls both front and rear, and even then the overpressure could rupture eardrums. The ideal firing position was on a flank or reverse slope, where the team could fire once or twice then, displace before return fire arrived. German tank destroyers in World War II had developed similar tactics, and American infantry studied German after-action reports extensively when developing bazooka doctrine. One of the most effective tactics, developed in Korea and refined through hard experience, was the ambush lane. Infantry would identify likely avenues of approach for enemy armor, places where terrain channeled tanks into predictable routes. Multiple bazooka teams would position themselves in depth along these lanes, each team responsible for a specific killing zone. The lead tank would be allowed to pass the first team and engage by the second or third, ideally with side or rear shots. The trailing tanks, seeing the lead vehicle destroyed, would typically button up and attempt to reverse, presenting their thinner rear armor to the forward teams. Coordinated with mines, anti-tank guns, and supporting infantry, this defense in depth could devastate an armored column. The North Korean People's Army learned to avoid obvious choke points and never advance armor without extensive infantry reconnaissance, direct result of losing dozens of T-34s to well-planned bazooka ambushes. The Super Bazooka also found use in urban warfare, a role for which it proved remarkably well suited despite its limitations. During the fighting for Seoul in September 1950, Marines used M20s to clear buildings, blasting through reinforced walls and bunkers. The shaped charge warhead, designed to penetrate steel, proved equally effective against concrete and masonry. A single well-placed rocket could collapse a room, seal off a tunnel entrance, or demolish a reinforced machine gun position. The Marines developed a technique of firing into buildings at ground level, where the rocket would penetrate the wall and detonate inside, the blast and fragmentation clearing multiple rooms. This was dangerous work as the firer had to be very close, typically under 50 yards, but it was often faster and safer than assaulting through doorways. The sound of the Super Bazooka firing became one of the distinctive audio signatures of the Korean War. The launch made a deep whooshing roar, quite different from the sharp crack of conventional weapons. The rocket motor burned for about a quarter second, producing a sound described by one soldier as like God tearing a bedsheet. In flight, the rocket made a rushing, whistling noise that rose in pitch as it approached the target. The detonation, when the shaped charge warhead struck home, was not the sharp bang of high explosive but a dull, heavy thump followed by secondary explosions if the target contained ammunition or fuel. North Korean and Chinese troops learned to recognize the sound sequence and would immediately seek cover, knowing that if they could hear the launch, the rocket might be heading toward their position. Captured enemy documents from the Korean War revealed the respect and fear the Super Bazooka commanded. A Chinese People's Volunteer Army Training Manual from 1951, captured during the Spring Offensive, included an entire section on countering the American Big Bazooka. The manual advised tank commanders to never approach American positions without infantry support, to avoid predictable routes, to engage bazooka teams with machine gun fire from maximum range, and to immediately retreat if a rocket struck but failed to penetrate, as follow-up shots were certain. North Korean tank crew training emphasized identifying and eliminating bazooka positions before advancing, even if it meant expending main gun ammunition on individual soldier positions. The manual noted that American bazooka teams typically operated in pairs, and that destroying the first team did not guarantee safety, as the second team was likely already moving into firing position. The logistical requirements for maintaining Super Bazooka operations in Korea were substantial. Each rocket cost approximately $18 in 1950, equivalent to about $220 today when adjusted for inflation. With thousands of rockets fired monthly, the ammunition expenditure represented a significant investment. The rockets had to be transported carefully, as rough handling could damage the fins or deform the shaped charge liner, reducing effectiveness. In Korea's extreme cold, special precautions were necessary. The solid rocket propellant became brittle below -40°F, and several rockets shattered when fired during the brutal winter of 1950 and 51. Ammunition handlers learned to store rockets in heated tents and warm them before issue to forward units. The launcher itself required maintenance that was more complex than standard infantry weapons. The aluminum barrel could dent or warp if dropped, affecting accuracy. The electrical contacts in the magneto firing system had to be kept clean and dry, a challenge in Korea's dusty summers and wet winters. The optical sight was relatively delicate and easily damaged. Units in combat lost bazookas at an alarming rate, not primarily to enemy action but to the routine destruction of infantry combat. Soldiers diving for cover would bend or break launchers. River crossings would flood the firing mechanism. The weapon's length made it awkward in dense terrain, and more than one soldier damaged his bazooka by catching it on tree branches or scraping it against rocks. The standard replacement rate was approximately one launcher per month for every 10 in service, meaning that a battalion with 27 authorized bazookas could expect to need at least 2 or 3 replacements monthly. International sales of the M20 brought interesting variations and improvements. The French, using Super Bazookas extensively in Indochina and Algeria, developed tactics specifically for jungle and mountain warfare. French colonial infantry found that the bazooka was effective against the log and earth bunkers typical of Viet Minh fortifications. They also discovered that the weapon could be used against cave positions by firing into the cave mouth, the overpressure and blast effects being lethal to anyone inside even if the shaped charge jet didn't directly hit them. The French produced their own rocket variants, including an experimental fléchette round that scattered steel darts over a wide area, intended for use against massed infantry. This round never entered large-scale production, but demonstrated the versatility of the basic launcher design. The Israelis, who acquired Super Bazookas through various channels in the early 1950s, used them extensively during the 1956 Suez Crisis. Israeli infantry found the M20 effective against Egyptian T-34-85 tanks and Su-100 tank destroyers. However, they also noted significant limitations. The weapon was too heavy for the rapid movement tactics favoured by Israeli doctrine, and its relatively short range meant that crews had to close to suicidal distances against well-supported armour. After 1956, Israel increasingly turned to lighter, disposable anti-tank weapons, supplemented by heavier, longer-ranged recoilless rifles and eventually wire-guided missiles. The Super Bazooka remained in Israeli service as a bunker-busting weapon, but was relegated to second-line status for anti-armor work. Latin American militaries became major users of the Super Bazooka, with virtually every nation in the region acquiring substantial numbers through US military assistance programs. During the various border conflicts and internal insurgencies of the Cold War era, M20s saw extensive action. During the football war between El Salvador and Honduras in 1969, both sides employed Super Bazookas, attacking each other's light-armoured vehicles and fortifications. The Honduran military claimed several kills against Salvadoran M3 Stuart light tanks and M8 Greyhound armoured cars using M20s. The weapon proved more than adequate against these World War II vintage vehicles, whose armour had been designed to resist machine gun fire, not shaped to charge warheads. In Africa, Super Bazookas proliferated through military aid to pro-Western governments and through captures by insurgent groups. During the Nigerian Civil War from 1967 to 1970, Biafran forces used captured M20s against Nigerian armour with some success. The crude tactics employed, often firing from minimal cover at short range without proper support, resulted in high casualties among bazooka operators, but also achieved a significant psychological effect. Nigerian tank commanders became extremely cautious, often refusing to advance without overwhelming infantry support. Similar patterns played out across Africa through the 1970s and 80s, with Super Bazookas appearing in conflicts in Angola, Mozambique, Ethiopia, and elsewhere. Many of these weapons were decades old, poorly maintained, and fired ammunition that had degraded in tropical storage, yet they remained dangerous. The technical limitations of the Super Bazooka became more apparent as tank armour evolved. By the late 1950s, the Soviet Union was fielding the T-54 and T-55 medium tanks with substantially thicker armour than the T-34. The T-54's frontal armour exceeded 200 mm in places, and even the side armour was 80 mm thick, proof against the M20's 280 mm penetration at all but the most favourable angles. The Americans were producing the M48 and M60 tanks with similarly robust protection. Composite armour, spaced armour, and reactive armour concepts were under development that would eventually make shaped charge warheads of the Super Bazooka's size completely obsolete. The tactical response was to increase warhead size yet again, leading to weapons like the 120mm de Biat and eventually to wire-guided missiles that could deliver much larger warheads from much greater range. By the mid-1960s, the US military's doctrine had shifted decisively toward missiles for long-range anti-tank work and disposable weapons for close range. The M72 law, adopted in 1963, offered 66mm penetration, considerably less than the Super Bazooka, but weighed only 5.5 pounds loaded compared to the M20's 15 pounds, empty plus 9 pounds per rocket. More importantly, the law was disposable. The entire weapon was fired once and discarded, eliminating the maintenance burden and reducing training requirements. For situations requiring heavier punch, the M67 90mm recoilless rifle offered similar penetration to the Super Bazooka, but with much greater range, up to 450 yards effective. The M20's niche, the medium-weight reusable portable anti-tank weapon, was being squeezed from both sides. The final American combat use of the Super Bazooka came in Vietnam in the mid-1960s. Marine units deployed in 1965 and Army units arriving in 1966 carried M20A1B1 launchers, the ultimate American variant featuring a trigger mechanism redesigned for better reliability and a strengthened barrel. In Vietnam, opportunities to engage armour were virtually non-existent in the early years. North Vietnamese forces operated few tanks, and those stayed near the demilitarized zone or in Laos and Cambodia, well away from American ground forces. The Viet Cong had no armour at all. Instead, the bazooka's role was entirely focused on bunker destruction and fortification reduction. The M20 proved effective against the sophisticated bunker systems the Viet Cong constructed, particularly the reinforced fighting positions around base areas and supply depots. A shaped charge warhead could penetrate the multiple layers of logs, earth, and sandbags that characterized these fortifications, killing or stunning the occupants. However, the weapon had significant drawbacks in the jungle environment. Its length, made it difficult to maneuver through dense vegetation. The backblast cleared vegetation in a wide cone behind the weapon, often igniting dry grass or brush and marking the firing position with smoke. Most problematically, the weapon was heavy and ammunition-intensive for a role that usually required only 1 or 2 shots per engagement. A Marine squad humping through the jungle for days on patrol had no interest in carrying a 14-pound launcher plus 36 pounds of rockets when the M72 Law or M79 grenade launcher could do similar work with a fraction of the weight. By 1967, American forces in Vietnam were turning in their Super Bazookas and refusing reissue. The weapons were crated and shipped to rear area depots, then eventually back to the United States or to military assistance program recipients. Some ended up in the hands of South Vietnamese forces who used them through the early 1970s. When North Vietnamese armour finally appeared in strength during the 1972 Easter Offensive and the 1975 Final Offensive, the M20s still in South Vietnamese hands proved inadequate. The T-54 and T-55 tanks the North Vietnamese employed were largely immune to the 3.5-inch warhead from the frontal arc, and South Vietnamese bazooka teams suffered heavy casualties in futile attempts to stop the armoured advance. The more effective weapons were the wire-guided missiles and modern disposable rockets the Americans had provided, but there were never enough of these, and the training was inadequate. The Super Bazooka's export service life lasted considerably longer than its American career. Many nations continued using M20s into the 1980s simply because they had large stocks, no immediate replacement, and limited budgets for new equipment. The weapon remained adequate for its primary role in these militaries, which was not defeating modern Soviet armour, but providing infantry with some means of fighting light armoured vehicles and fortifications. Against BTR-60 armoured personnel carriers, BRDM scout cars and similar vehicles, the M20 was entirely adequate. Against bunkers and buildings, it remained effective. The fact that the weapon was obsolete against main battle tanks was irrelevant if your most likely opponents didn't have main battle tanks. Some nations manufactured their own ammunition to keep their M20s viable. Turkey's Mechanical and Chemical Industry Corporation produced rockets compatible with the American launchers, but incorporating improved propellants and more sensitive fuses. Pakistan manufactured rockets for their extensive inventory of bazookas, maintaining production into the late 1970s. These locally produced rounds varied in quality, with some being quite effective and others suffering from quality control issues that resulted in frequent malfunctions. The variation in ammunition quality became a significant issue, as Super Bazookas from the same production batch might perform very differently, depending on whether they were firing American, Turkish, Pakistani, or other manufacturer rockets. The Iran-Iraq War of 1980 to 1988 saw one of the last large-scale uses of Super Bazookas in conventional warfare. Both sides possessed M20s, though in limited numbers. The Iranians, cut off from American resupply after the 1979 revolution, used their existing stocks of bazookas primarily in defensive operations against Iraqi armour. Iraqi forces, better supplied with modern Soviet anti-tank weapons, rarely used their older M20s. The battles around Khorramshahr and later during the Iranian offensives into Iraq saw occasional bazooka engagements, usually with poor results. Iraqi T-55, T-62 and T-72 tanks were effectively immune to the 3.5-inch warhead, except from the rear. An Iranian bazooka team suffered catastrophic casualties attempting to close to effective range across open terrain. The weapon found an unexpected renaissance in asymmetric warfare. Various insurgent and irregular forces discovered that the Super Bazooka, while obsolete against modern armour, was still highly effective against unarmoured and lightly armoured vehicles, aircraft on the ground, buildings and personnel concentrations. The weapon's reusability meant that once a group acquired a launcher, they only needed to obtain rockets, which were easier to smuggle or manufacture locally than complete weapon systems. Palestinian groups used captured or smuggled M20s against Israeli positions during various conflicts. Lebanese militias during the Civil War employed them extensively. Afghan Mujahideen fighters acquired small numbers and used them against Soviet vehicles and helicopters, though they vastly preferred the more modern and capable RPG-7. The last confirmed combat use of the Super Bazooka by a regular military force occurred during the Gulf War in 1991. Iraqi forces had some ancient M20s in the inventories of reserve and militia units. None were successfully employed against coalition forces, as coalition air superiority and the speed of the ground campaign prevented effective Iraqi defensive operations. Several launchers were captured intact by coalition forces and sent to museums or intelligence agencies for historical interest. At this point, the weapon was nearly 50 years old, a remarkable service life for any infantry weapon, but one that had clearly reached its end. The M20 Super Bazooka's place in military history is secure. It represented the culmination of the shaped charge rocket launcher concept, taking the flawed original bazooka design and refining it into a weapon that actually worked as intended. Its 11 to 13 inches of armour penetration, while eventually rendered obsolete by improved tank armour, was more than adequate for the threats it faced during its peak service years in the 1950s. The weapon's reliability, manufacturability and effectiveness transformed it from an emergency stopgap deployed to Korea in desperation into a standard that influenced anti-tank weapon design worldwide. The Soviet RPG-2, introduced in 1949, and its successor, the RPG-7, introduced in 1961, both reflected lessons learned from studying captured bazookas and Panzerschrecks. The RPG-7 in particular became the most prolific anti-tank weapon in history, with over 9 million produced. While differing in details, the basic concept of a reusable launcher firing shaped charge rockets traces directly back to the bazooka. The Chinese Type 56 rocket launcher, the North Korean Type 68, and dozens of other weapons around the world represent the global spread of the technology that began with Robert Goddard's 1918 demonstration and reached maturity with the M20. For the soldiers who carried it, the Super Bazooka represented something more fundamental than technical specifications. It represented the promise that infantry would not be helpless against armour, that a determined man with the right weapon could stop a tank. In World War II, that promise was only partially fulfilled. The 2.36-inch bazooka worked sometimes, under the right conditions, with good luck. In Korea, the 3.5-inch bazooka turned the promise into reality. When you fired the Super Bazooka at a T-34, the T-34 died. That certainty, that confidence changed everything. German infantry in 1943 had laughed at American anti-tank weapons because those weapons failed. North Korean tankers in July 1950 ignored American anti-tank weapons because those weapons failed. By August 1950, no one was laughing, and no one was ignoring the threat. The Super Bazooka had arrived, and the rules had changed.